All right, let's take a look at extending now on our planetary gear out towards this point D and seeing what's going on with the black ring. So I kind of summarized what we did in a previous video. We know that the velocity of A is stationary. We already talked about the fact that the purple disk is not rotating, so omega of the purple disk is 0. I should put that in here. So omega of the purple disk is 0. But the blue bar is moving with some omega AB. We'll say that we know that. Maybe we don't, maybe we know something else, but we'll call that a known. Our radii are going to be known, and this angle theta is a known value. So previously we discovered that the velocity of B with respect to A was equal to the omega value of AB, that's the blue bar, crossed with the position of B with respect to A. And we said that that's some speed at an angle of theta plus 90 degrees, because again, remember, the velocity must be tangent to the circle, which means it's perpendicular to the radius. Okay, and then the velocity of C with respect to A, that's this contact point between the red gear and the purple gear. That C, that has to have a velocity of 0 because the purple gear is stationary. And so we set that equal to 0. So in here, we're probably going to be able to find out what this omega BC is. Maybe we know the omega BC, and we go back to find omega AB. Systems of equations, right? I don't know which is going to be known and which is going to be unknown in that particular problem you might be working on. But we'll be able to solve that system of equations. All right, so what's going to happen over here at D? Let's take a look at that. So as I look at D, I could say that the velocity of D with respect to A, that's going to equal omega of the black gear, right? And that's going to be in some k hat direction. Might be clockwise, might be counterclockwise. I don't really know at this point. So I'm just going to say omega times k hat. This could be negative. And then I'm going to cross that with the position of D with respect to A. And that I do know. That's going to be the radius of the purple plus 2 radii of the red, right? And that's going to give us the radius of the black, which I guess I have up here. But that's got to be the radius of purple plus 2 radii of the red. So technically, I might not know that. Or maybe I know the radius of the black and I can solve for the radius of the red. Again, we'll have some unknowns that we have to work out. We don't know what they are because they'll be different from one problem to the other. But there's that relationship. So let me go ahead and put the radius of the black back in here. But of these 3, I only need to know 2 of them and I can find the other one. All right, so I know what this is. And that's a vector quantity. It's going to be the 2 radii at an angle of theta. So I could write it out there very similar to what I did here with the magnitude of the speed and the angle. I could put that in polar form and then I can transfer it into Cartesian coordinates as well. But the other thing I know is that the velocity of D with respect to A is equal to the velocity of B with respect to A. And we've done that up here, plus the velocity of D with respect to B. All right, so the velocity of D with respect to B. Well, let's see here. This red wheel is rotating, and so the velocity of D with respect to B, okay, let's put the velocity of B with respect to A up here again. The velocity of D with respect to B is going to be omega of the red gear, which I call BC currently. It's the same, BD or BC, doesn't matter. That's in the k hat direction. Crossed with the position of D with respect to B. But this is just going to be the red radius at an angle of theta, right? Because it's coming off at this same angle, but it's the red radius. So I know this, and I know this, and I know this. So I can find the velocity of D with respect to A. And once I have the velocity of D with respect to A, I know the radius, I can tell you how fast the black gear is rotating. And so from using one step to the other, okay, I go from A to B, from B to C. That's what I did in the previous video. And then now I can go from A to B and from B to D, and I can get more information about what's going on that outer piece. I've done this all assuming the purple gear is stationary. We can do it with the purple gear not being stationary, but then we're going to have something given so that we can find all of this information out. If the purple gear is not stationary, this argument of the velocity of c with respect to A being 0 is incorrect. But what would we have? We would just have the velocity of c with respect to A is equal to omega of the purple gear. I'll just call that omega purple, crossed with the position of c with respect to A. And so something's going to have to be given in order for us to find that information. All right, so I think I've given you a good flavor of how these problems will work. Again, it doesn't matter whether it's a planetary gear or a sun gear or a rod or a garage door, whatever. They all have the same concept. You know some omegas, you look at positions, and you go from one position to the next using relative motion until you figure out who's moving and how. All right? If you have any questions, be sure to leave them in the comments below. Thank you.